All right, so now on to name the other large class of compounds, which are molecular compounds. And the biggest, easiest way to figure out what these are compared to ionic compounds is these usually consist of two nonmetals. So ionic formulas had a metal and a nonmetal typically. These will usually have two nonmetals. So if we go back to our periodic table, remember the nonmetals are to the right of this staircase. So if you see two of these, that's usually going to be a molecular compound. So if we look N and O, these are both nonmetals, so this is molecular. Br and O are both nonmetals, C and O, S and F. There's no metals involved at all here. Sometimes another hint that you're dealing with a molecular compound, the subscripts are generally larger. You're going to start seeing sixes now, and sevens and eights. That's not always going to work, but sometimes that will give you a hint. So how do we do molecular compounds? The same as ionic, we're going to divide these up. So we're going to separate. It's a little easier to separate because there's only two atoms that we're going to be dealing with. And we're just going to look at them and we're going to name them. So the first one is nitrogen. So I've got nitrogen. And unlike ionic, we actually do have to list how many there are here. So for example, N2O4, I have to say dinitrogen. I can't just leave it as nitrogen. And then oxygen. So oxygen we know is oxide, but there are four of them. So I have to go to my list of prefixes. So the prefix for four is tetra. So I'm going to say dinitrogen, and tetraoxide doesn't. Anytime you're dealing with an oxide and you have a prefix that ends with a vowel, what you're going to usually do is drop that vowel. So instead of tetraoxide, we're going to say tetroxide. That's a minor thing. I don't know if that will be a big deal, but if you want to get it exactly right, we will drop that off. So dinitrogen tetroxide. And the reason that we do this is without the prefixes, we'd have no idea what the formula is. For example, I can have nitrogen. If I just wrote the formula nitrogen oxide, there are so many different compounds this could be. It could be NO2. It could be N2O4, N3O6. There are so many different ways it can form. So we need prefixes that tell us what the formula is. We can't rely on the charges to solve it for us like we could with ions. And so that's why the prefixes are necessary. So next, Br3. So Br is bromine. And 3, you're not probably surprised, 3 is tri. So this is tribromine. Oxygen, again, is oxide. And 8 is octa. I'll go back to that later. But again, oct. I'm going to drop the A. So I'm just going to call it octoxide. All right, now CO. So C is carbon. And O is oxide. Now, looking at this one of each. Now, looking at the prefixes, one is mono. And so you might be tempted to say monocarbon monoxide. But you've probably heard of a chemical for this before. We don't ever use mono on the first one. So we'll just cross that off. The next one will. It's not going to be monooxide. We are going to drop the O. So again, don't use mono on the first one if there's one. So carbon monoxide. We do need the mono on the second one, but never put it on the first. Just sounds strange. And if you're ever unsure, go back to this example of carbon monoxide. Same thing for the next one. We all know what CO2 is, right? It's carbon, and 2 is di. It's carbon dioxide. So not monocarbon dioxide, just carbon dioxide. SF6, sulfur. 6, I'm going to show you in a minute, is hexasulfide. What am I talking about? We already had sulfur. Hexafluoride. Again, we always have to put the second one end in I. Unlike ionic, there's none of this 8 stuff. They all end in I. All right, Cl2O. So chlorine, it's dichlorine. Then one oxygen is monoxide. So I think the routine for this is a lot simpler than ionic. There's not a lot of crazy exceptions except for this mono on the first one. What's tricky about molecular is it's one of the few times in chemistry where we actually have to do some memorization. You need to know these prefixes. So just to give you some quick tips on that, mono, monologue is one. There's this, mono, I think for the most part people get okay. Die. As far as die, you have words like dialogue, between two people. Diatomic, which is in chemistry, means two atoms. But so just, we need to learn that die is the prefix for two. Tri, no one usually has trouble with this. Tricycle is the common way to remember it. Tetra, a lot of people forget that tetra is 4. And one way to remember that is if you remember the game Tetris, every single block in Tetris it consists of 4 squares. So when you think 4, it's Tetris, tetra. So that's how you can remember that prefix. Penta, pentagon, no one usually has trouble with. Hexa, hexagon, again, same deal. Hepta, sometimes people have trouble with that. Just remember to keep this H here. It's hepta. Octa, no one usually has trouble with. Octopus, things like that. Octagon. A lot of these are similar to geometry. Nona is 9, like nonagon, which is a symbol, shape you probably rarely encounter. But deca, decade, decagon, decathlon. So these are some hints to help you remember these, but really you just got to study these and just commit them to memory. It's one of the few times you'll have to do it in chemistry. But once you have those down, you should have no issues with molecular naming. The only thing is making sure you identify what is a molecular compound versus ionic. Again, you're looking for 2 nonmetals. That's usually the giveaway for that. So, until next time, I am Derek Genova. Have a delightful day.